Here we go, 10-3, wrapping it up. I'm going to kind of go through this rather quickly, talk about what's going on. It says, you know that a system of linear equations can have exactly one solution, infinitely many solutions, or no solution. If the coefficient matrix A of a square system is invertible, then the system has a unique solution, which is defined as follows. So if A is invertible, then the system of linear equations represented by AX equals B has a unique solution given by A equals A inverse B. What? X equals A inverse B. What did they just do there? How did they get from AX equals B to X equals A inverse B? Right. So what we have here is we multiply the left side by A inverse, and then we multiply the right side by A inverse. And by definition, what is A inverse A going to equal? 1, or the identity matrix, right? So that's gone, leaving us with X equals A inverse B, which means if I can take a system of equations and write it in matrix form, find the inverse of the coefficient matrix, I can multiply both sides by that coefficient matrix, and it gives me the answer. And so here's what that's going to look like. And I'm not going to go through all the steps of doing this, okay? So here's a matrix. If I was to write this as A, X, B, it would look like this. My coefficient matrix would be 1, 1, 1, 0.06. Give myself big enough space to write. 0.075 and 0.095. Last row, 1, 0, -2. Y'all good with that? My variable matrix would be what? No, my variables. X, Y, Z. Y, Z equals B. B is my coefficient. I'm not my coefficient. B is my constant matrix. My constant matrix is okay. So what I need to do is find the inverse of this guy. Okay. Lots of ways of doing that. We've talked about them already. I'm going to the next slide. So once we do all of that, we find out that the inverse of 1, 1, 1, the inverse of that is right here. I'm not going through the process of giving you that, of solving for that inverse, but there's the inverse. Because I know that this is the inverse, I can take that and multiply both sides by this inverse. Putting this inverse right here makes this the identity. Then I have to put the inverse right here, correct? Remember, order is important, right? It has to be before it. Okay, going on to the next slide. So here is my inverse matrix, and I take that inverse matrix and multiply it by my constant matrix. And remember, it's row by column, right? Let's just talk through that real quick. If I took this row times this column, what does that give me? $15 times 10,000, that is, I'm going to go with 15,000. 15 times 10,000 is 15,000 plus, it's okay, 150,000. That's what I said, 150,000 plus negative 200 times 730 plus 0. Now, if you add those together, do you get 4,000? You do, right? And so that's what's going on. Should I go through another one or y'all good? Anybody do another one? Do another one? Yes, no? I would do this row and this column, and that goes here. And then I would do this row times this column, and that answer goes here. Yeah. What are the dimensions of my inverse? Or what is the order? 3 by 3. This is a 3 by 3. What is the order of this guy? 3 by 1. Always rows first. Rows by columns, always. Look at the inside number. Can we multiply them together? Yes. What are the dimensions of the answer? The answer is a 3 by 1. Okay. Questions? Comments? Complaints? Concerns? Cares? I don't either. Okay, I'm going to stop the